Okay, so whenever we talk about data visualization, the first thing that appears in our mind is why do we basically need it? I mean, why, what are we going to achieve from creating some plots and visualizations? I mean, if you have an Excel sheet of 30,000 rows, it is not convenient for you to go through the 30,000 rows and see what is going on in the file, right? So a better thing to understand the different patterns and different insights from the data file is to just create some visualizations, and from those visualization you can identify different patterns, and these patterns can help you to communicate. Like if you are trying to explain something to someone, or if you're working in a company on company database and you have to tell the stakeholders about your information, so it's much better to just share some visualizations. They are easy to understand and they will look at them, and you have to use less words and more graphs, and it will be quite easier for you to convey your message. In decision making, it also helps you, because whenever you create some plots, you identify some key problems and key insights from the data due to those figures that you could not understand by just looking at the Excel sheet or the data file. No, these are few things that we need to understand, that why we need to create data visualizations. Now, in data visualizations, we have different kinds of plots. We have bar plot, count plot, pie chart, histogram. We will discuss them. We will discuss all of them in detail. So let's start with the bar plot or bar chart. No, bar chart is basically a plot that we use something like this. It's called bar plot, and it is used to whenever we are working with categorical variables. Like we are variable with different categories. Here we have variable with male and female, but if we have 3 to 4 categories or more than that, we will go with the bar plot. Okay. And when we combine bar plot with the, like there are two different kinds of bar plot. Now here we have, for example, we have males and females. In our data files, there are 4 males and 2 females. Now this is a count plot. Okay. Why? Because it is showing us the actual number, how many time males appears and how many time females appears. We call this count plot. It shows the frequency distribution of categorical variable, like that how many time each category is appearing in our data file. But for example, if you're saying that the average marks for male is 4 and average marks for female is 2, now this is not a count plot. It is not representing count now, it is representing some metrics, right? And whenever we have such a case, we will not call them count plot. Instead of that, we will call them bar plot. At the end of the day, both are same thing. Count plot represent the appearance of each category, and bar plot or represent something, that some metrics that we want to show to the audience. After that, we have a pie chart. Pie chart looks something like this. Now, what does it show? It shows the proportion of different categories. For example, we can use this pie chart to represent count plot as well. Like if we have male and female, 80% male and 20% female, we can use it to show that. Also, we can use it with any kind of matrix to represent that. For example, if we want to show the marks in different categories or something like that, we can also use it as well. It also helps you to compare them side by side in the percentage sense. Like by looking at it, you can see that this one has 27 point some percentage and all that, because we show that on our plot. And it's best whenever we have less than 5 categories. Like if we have more than 5 categories, we should not be using pie chart, because it will become a mess. After that, we have histograms. Now, the histograms and bar graph look similar, but they're two different things. Histogram is used whenever we are working with numeric columns, whenever we have numbers, and bar plot is for the categorical ones. Now, what is basically a histogram? Histogram shows the distribution in the numeric columns. Like for example, in that particular case, we have data something like 38, 30, 35, 45, 15, and 75. Okay, and when we create a bar plot, we see that we between 30 to 45, we have 3 entries. apart from the apart from this interval, we have only one categories in each. Okay, now this is basically showing the distribution of data, how our data set looks, and how many entries we have in different intervals. Okay, and these intervals are also customizable. We can use bins to reduce the size of them, to increase the size of them, and all that. We will go through it when we are coding and we're creating the plots. After the histogram, we have box plot. If you remember in previous session, we talked about that we have normal distribution and we have uniform distributions, right? Histogram basically helps us to identify that as well. If we created a plot and it looks something like bell-shaped with its normal distribution, and if we know that our data is normally distributed, we can use all kind of algorithm that assumes the normality in the data. Also, if our data set is uniform, we can also identify it from here with the histogram. Now, box plot is also a similar thing that it is used for the numeric columns to visualize them. Now, in histogram, we see the overall distribution, but in the box plot, we see something like that. So, box plot shows the outliers. Like if we have an outlier in the data, it shows that this particular entry is an outlier and it's far ahead from the rest of the data. And we see a big box here in the middle, and this box basically represents that 75 percentile of the values remain in that particular thing, right? Like for example, now in that case, let's talk about it. We are discussing, I think, this data 38, 30, 35, 45, 15, and 75. Okay, now this value 75 is far ahead from rest of the data. That's why it's treating it as an outlier. Okay, and if we take a median of it, like where the 50% of the values lies, we will see that this is something around 35 or 36. So this particular middle line basically represents the median. And the first line tells us about the 25th percentile. 25th percentile means we are at this point, like at 32 or something like that, 25th percent of the values are less than this point. Okay. And so next 25% values remain between 32 to something like 38 or 37. And in this way, like we can identify the 75th percentile, like 75th percent of the values is less than 44 or something like that. And now this particular line represents the minimum value. This is the minimum value in our data set. This looks around 15. I think it was 15. Yes. And according to the box plot, this should be the maximum line, and this particular value should be treated as outlier. Okay. And in our case, 75, it is excluding it and it's saying that that's an outlier, and 38 is basically the final value. Sorry, 45 is basically the final value of the data. So that's what box plot do. It shows numeric column and it shows these different matrices to identify that what actually we're dealing with. Now, for example, if we are working, if I have a class, I am teaching 100 students and I need to show the results to something in administrative, I can just create a box plot and I can show them. And the box plot will show, the middle line will show that most of the 50% of the students lies around here, and only this particular percentage is less than 25th percentile and all that. After box plot, we have violin plot. Violin plot looks something like it's similar to box plot, but just a different visualization style. Okay. And if I say, no, this is the box plot and this is violin plot. It looks similar, but it is just a different visualization style. We have a middle line same as that inside it in white. We also have these two things, and instead of these lines we get something like this. Okay, and it does not show outliers, it will just treat them everything in a single way. After that, we have scatter plot. Scatter plot is used to show two numeric columns. Like if we have two numeric columns that we're talking about, we can use scatter plot to represent that. For example, we have a data set it's small data. We have John, we have a marks related data set, and we have age and marks for different candidates in our class. And if we want to create a scatter plot, we will only use numeric columns like marks and age. Okay. Now the scatter plot looks something like this. Each point represent a line in our data set. Like for example, if we are talking about the John, his age is 38 and he got 78 marks. So we will go and see on 38, we will have 78 marks. So this point basically represent John. So each line is basically a point in the data. No, that's what we call a scatter plot. Now, why do we need to create scatter plots? Scatter plot basically helps us to identify relationships. For example, before that particular session, in when we are talking about data cleaning, data preprocessing, we stated that we are imputing the missing values with the mean, right? So we have missing values in our data set and we want to treat them and we take average and put on these missing values, right? But suppose we are talking about something like this. For example, we have a data set and we are saying that this column is related to nutrition and this column is related to health. Okay. And we have a there are some patients and we are giving nutrition to different numbers of patients, and with that health is getting improved. Okay. And now if we look at it, if someone is taking nutrition 1, 2, 3, 4, he is getting his health points are quite higher than the one who is taking nutrition at level 1. Okay. Now this is just an example to understand. And suppose we have an entry at, for example, 8. Okay, and we don't know about its health points. And we take all the values and we take the mean, and mean pairs something like here, and we give it a value like 3 in the nutrition, right? Now the problem is we know that with the increase in nutrition, health score also increase. But when we talk about imputation with mean values, we ignore that fact, right? So that's what scatter plots do. It identifies that there is some kind of relationship between these two. If nutritions are increasing, the health score should also increase. Okay. Now, if we're talking about this particular thing and nutrition should not be here, it should be something around here because we are increasing the nutrition. This is just an example to understand that how scatter plot can identify us the simple relationships that we should not just rely on the book matrix or something like that. After that, we have bubble chart, heat maps, pair plots, tree maps. Now, the tree maps, bubble charts, they are very specialized charts. I mean, we don't use them all the time. It once in a lifetime you might use them because they are not the academic standards or industry standards. So they are very less likely to be used. Okay. Most of the time you will be dealing with scatter plots, histograms, box plots, and bar chart. Okay. Now let's dive into the coding. We already know that whenever we talk about data visualization, we talk about two different packages in Python, matplotlib and seaborn. So we will start with the matplotlib and then we will discuss the seaborn. As we talked earlier, whatever we need to do, we just need to import the packages that we are going to use. In that particular case, we are using matplotlib to create the visualizations, NumPy pandas for different data manipulations and creating data and all that. SNS is also seaborn that we're going to use for data visualization. Now, these particular lines of code are related to the chart style. If you don't write them, that's totally fine. We are just specifying the width and the height for our figures. We just create a simple data sets, like we are creating 100 entries between 0 and 10, 0 and 10, and we are saying that divide it into 100 different values and they should be equidistant, and we are creating a y value with the sign x. No sign, I'm assuming that you know sign theta or something like that. Sign is basically a mathematical term that when whatever value we give it to you, it map the values between 0 and 1 and -1, so we will get something like this. Okay. Now, if you want to see how our data look like, you can also see that by just creating a new code and write x. Now, x looks something like this. The first value is 0, the last value is 10, and it is divided into 100 values. Okay. And if we want to see the y values look something like this. So basically, y is a mathematical operator sine theta that isolate the values between 1 and -1, so something like that. Okay. Now, the data is just a dummy data we are creating to study the visualization. So data is not important, but the visualizations are. The first plot we're going to create is a line plot. Now for line plot, we don't need to do anything fancy. All we just need to do is plt dot plot. And here we will specify our data points. Like first one is x and second one is sine y. Okay. And since x contains 0 to 10, so we are going to show something, see something like values between 0 to 10. And in the y, values will remain between 1 and -1. So that's why we are seeing 1 and -1 here. Okay. Now, from data visualization perspective, only thing we need to understand is whenever we write plt.plot, we are basically creating a line plot, and in it, we need to provide two numeric columns to create the line plot. Okay. And now this particular data is smooth, like we are not getting values. Every value is in every next value is basically continuation of the previous values. So we are creating a smooth line, right? But if we have a messy data file, we might not be able to create something like this. Like for example, if we are talking about this particular data and we're trying to create a line plot, so it will not look as neat as this one or smooth as this one. We will get something like this, and it will be a total mess. Okay. So we use line plot whenever we're talking about something related to time. For example, number of students in year 2001, 2, 3, 4. No, they are going to be a smooth continuation rather than a mess. Like we are we time is in one dimension. Like we are not going to talk about if 2001 has this many years, then we will go back. No, we will only continue in one direction. 2001, 2, 3, 4. So basically the line plot is kind of sensitive plot that only works when data is 100% compatible and one dimensional. Like every next value is independent from the previous one. Now, for example, this in this plot, if we create a line plot, it will be like a lot of mess that we cannot even understand what we are doing here. So this was the line plot. Now all we need to do is plt.plot to create the line plot. But if we want to create a scatter plot instead of line plot, we need to use plt.scatter. Okay. Now, till now we are talking about the bare bone plots. We are talking about the bare minimum that we need to do to create a plot. Okay. All we need to do is just use plt.scatter or plot and provide the values for x and y and a plt.show to create the show the image. Here we use scatter plot. That's why we're getting a scatter plot. And for the data, we just take random 50 numbers and random 50 numbers in x and in y. And now let's talk about the bar plot. plt.scatter, plt.plot, and for the bar plot, we will have plt.bar. Now here we need to make sure that the first thing is categories that we're talking about, that we will give on the x-axis. The second thing should be the values, or the thing that we want them to represent. It will identify that this one is a bigger one, and it will create a bigger chart for that. It will do it on its own, so you don't need to worry about that. Now let's talk about the customization. Now we know creating plots is simple. We just use plt.plot, plt.scatter, plt.bar, or something like that. Now, if you create something like that, Like plt.plot, it creates a single line. But after that, you don't use plt.show. Instead, you use another plt.plot. So you will basically represent two lines on the same graph. Okay. Again, we are creating some data points to visualize. But whenever we're working on our own data, we don't need to create data. Here we are creating the data based on the cos function and the sine function for the values between 0 and 10. Now let's talk about the figure size. If we want to modify the figure size, we can modify it from here. plt.figure. Figure is equal to the width and the length of the file. Now we'll create first line and then second line, and for the first line we will just use plt.plot x. Now the thing that we need to understand is if you're adding more than one line on our single plot, their x-axis should be the same. Like it should be between 0 and 10. If it's for the first line, it's between 0 and 10. For the second line, it should also be between 0 and 10. For example, we have a line plot something like this between 1 and 5, and another line is between somewhere between here between 20 and 25. So the plot will look very odd and it will be quite high in width, and we cannot represent that on a single page or something like that. Okay, so if we are using more than one line, we need to understand that their x-axis should be common. Then we should assume that we can use that particular plot. But here, since we are creating sine x and cos x both from 0 to 10, so it's going to be the same and we can use it, right? Now, in the introductory session, we understand that from plt.x label, we can modify what's pairing on the x-axis. Like for example, here we have x values. If we want something like this, two lines, we will see that. In the same manner, we can modify the y label, we can modify the main title, and not only the text, we can also modify their sizes as well. Like here we have 12 size. If I select 8, it will be much smaller. Now two lines is much smaller, but y values is much bigger because we only modified it for two lines. Okay. Apart from that, we can also mess around with the colors as well. Now, since colors are 100% related to the line, so that's why we will change the color in the function that we are using to create the line. Like from here, we are using plt.plot, x value, y values, line width. Like if we want to make the line thicker, we can just increase it and we will get a more thick line, right? We can also modify the color if we want to, and something like that. And here we specified the line style with the two hyphen signs. Like if we want a dotted line like this, you can use it. But if you don't specify the line style, by default, it will just create a solid line. After that, we have a grid function. plt.grid basically helps us to create the background grids like the blocks. And alpha is basically the sharpness of these graphs. Like it should be around 0.3 and 0.5 because we don't want to make it much highlighted that we cannot even understand what we're trying to do with the data. Like if I convert it to 1, we will get something like this. So basically it will increase the color and the sharpness of the lines. Okay, but on standard we just go with the bare minimum. So basically they don't overshadow our main thing. After that, we have a tight layout function. It will basically make the graph little bit more eye pleasing. If we don't want to add it, we will get something like this. Okay. Now, these were some customizations that we can do inside the plot from images, from graphs, like the x-axis, y-axis, title, the line styles, and different the line sizes as well. Okay. If we want to save any graph, all we need to do is again the same thing. We need to specify title, labels, the actual graph. After that, we can use the function plt.savefigure. Okay, by using that function, we can save it in an image file, we can save it as a PDF file, and how we want to, it's totally up to us. Okay, so if we are trying to save it as a PDF, all we just need to do is remove it as a comment. So basically it should work, and when it works, we will see another PDF file with the name sinewave.pdf. Now here we just created a PDF file, and if we want to look at it, we can just open it and it will be a high definition PDF file. Like if we are trying to add these graphs into some report or something like that, we don't want to copy it from here because it will reduce the quality of the graph. So we will go with something like that by just creating a PDF file and then extracting the image from there. Okay. Now let's talk about the Seaborn. Seaborn is built on the same matplotlib. We can use Seaborn to make our graphs more visually appealing. For this, we are taking a data from the Seaborn package and we will use it to just show you that how these graphs looks in the Seaborn. Now the syntax and all that is little bit different, but at the end of the day, we are getting actually the same thing from both of them. If we want to create a bar plot, we will say sns.barplot. In the matplotlib, we say plt.bar only. And here we have to specify the data that we're working on, like if we're working on tips and what column we are talking about. Like for in the tips data, we're talking about the day column and the total bill column, and it will create the bar plot from here. Okay. Now the SNS package basically add these confidence intervals. So it basically shows that on the higher end, it might increase to this particular number, and at the lower end, it might decrease to this particular number. So basically, it's a confidence interval that we say that this value will remain between these two. This we already discussed the subplot command. So basically, subplot command helps us to create images in the grid fashion like this. Like for example, now here we have values like this 1, 2, and 1, right? Now this is number of rows. Okay. Now if we have values 1, so it means we have one row with two figures. Okay. Something like this, figure 1 and figure 2. And if we have here 2 here, so we are basically talking about this thing. Like we will have something like this, 2 rows and 2 columns. Okay, and the last number basically represent the index. Like if we're talking about 1, so we are adding image here. If we're talking about 2, we are adding something here. Got it? Now here we are creating two plots, and this particular plot is going to be the first position, this one, and this particular plot is going to be the second position. Now the good thing about the SNS is we can use different things to represent different things. Like for example, here in our data file, we have a columns like total bill and time. Like here we have the categories like dinner and lunch. So basically we can represent both of the things, total bills and the lunch at the same time. Okay, all we need to do is we need to use hue. Hue basically means to represent this particular column as a color. Okay, and we will see something like that. Now this is showing the total billing distribution, but with the dinner and lunch as well. Okay, now if we have a much higher total bill, we can see that this is dinner time bill, and that's why we're getting much higher. Got it? And we can also from here we can identify that the lunch proportions are quite on the lower end in the billing terms for as compared to the dinner. And the same thing we can do with the scatter plot as well. If you are trying to create scatter plot between total bills and tips, that are two different columns in our data set, and we want to see a third column, time as well, and size as well. Basically, there are two different to another columns in. So we are trying to represent 4 columns at the same time. Okay. Now this was the bare bone graph. Total bills and tips, we are getting something like that. Okay. And we want to see the time as well. We will just add time as hue basically for color, and we will see something like that. Now the orange basically represent dinner time and blue represent lunch time. We also added the size column. So basically, if a point is bigger, it means it has a great larger size. Do you understand? Basically, size is a column in our data set.
Yes, yes.
Perfect. And here we use box plot, violin plot, and basically the same thing presented with the data, added the X column and Y column, added the title for our figure. Basically, we are doing the same thing on different subplots, like we are creating this. Now, another thing that we need to understand is correlation. And the correlation, I think we should not start yet. We should start it with the linear regression. So I'm skipping it for now, but we will get back to it. Pair plot, we also know that there is a pair plot that basically plots everything in the data at the same time. So if we don't know what we're trying to do, we just use pair plot and it will create all the plots. And from here, we can see that what looks better to us. Got it? Now, in this particular data set, we have a categorical column with 3 categories, like 3 species, and it's representing them with green, orange, and blue. Here we are adding a title in it. We are adding the position for title. So basically, if we reduce this number, this title will get into our figure. If we increase this number, we will create an empty space. Like if I instead of 1, I will just replace it with 5. Now we just created this additional extra space that we don't need to, and now our graph looks mess. Okay. So basically, this is just for the position of this particular title. If we reduce it, will around 1, it looks perfect on our figures. Now there are some examples at the end that you can explore, and basically quite the same thing. If you think something is you cannot understand, just let me know and I will explain it. Okay. But they are quite similar thing, the customization that we can do with all kinds of plots.